Hello. Right, this one is another one on using a gas law. But this one is all about calculating the mass of gas. Gas does have a mass, although perhaps not a lot, but it does have a mass. So this one we've got air of volume, so that's the volume. So that should be meters cubed, look like it's volume now. So 0.75, there's one number, is heated to 120 degrees C. Okay, so that's our temperature under a pressure of 400 kilopascals. Don't forget the kilo means 400,000, so it's going to be 400 times 10 to the 3 on your calculator, or just want to do that, look, and just add 1, 2, 3. Right? Make sure you put the kilo. Right? That's the pressure anyway. The gas constant is 287 because every gas is different, so this is just a gas constant. So that's just a number depending on what gas it is. So we've got to calculate the mass of gas. Okay, and obviously the mass of gas won't change. Okay, but it might be spread out over a wider space. But so we've got to find the mass of gas. Okay, so the formula we use, nice and easy one. Here's the formula: PV. P is pressure, V is volume. That's got to equal M. That's the mass. R is the gas constant, and T is temperature. So just like we've done, P is the pressure, which we know, because it's there, look, 400 kilo. V is the volume, and we've only got one volume, so it's 0.75. Let's put it over there, 400 kilo Pascal. 0.75 cubic, that's the volume. Okay. We're not expanding it, we're not doing anything to it really, we're just heating it at that volume, so that's cool. M is the mass, which we've got to find. I don't know what the mass is. If we keep it in all the SI units, it'll come out in kilograms. So this is the one I don't know. I know that. R is the constant, the gas constant, which is just a number depending on the gas, which is 287. And T is temperature, which is 120. Don't forget, we can't use degrees C. You've got to convert it into Kelvin. Okay, so you've got to add, if you remember, you should remember, you've got to add 273 to it because we've got to be in absolute, right? Absolute 0 is minus 273. So we've got to be in Kelvin. So don't use 120, you've got to use 120 plus 273, which gives you 393. That's the number I'm going to use. Don't use 120. You've got to add 273, right, to get the absolute temperature. Okay. So we've got all the numbers. We need to find the mass of gas. How are we going to do that? Well, I know pressure. I know volume. I don't know the mass. I know the constant. I know the temperature. All I'm going to do is rearrange this formula for M. So I'm going to go P times V equals, leave the M there, bring them two down, R times T equals mass. That's the formula. Everyone's a winner. Okay. So we know the numbers. They're all in the right units. Make sure temperature's in the right units. Okay, so all I'm going to do now is do this. What was the pressure? The pressure was 400. Don't forget the 1,000. Perhaps put a bracket around it if we're going to do it all in one go. There. Times by the volume, which is 0.75. Okay. All divided by the gas constant, which is 287, times by the temperature, which is 393. Don't use 120. got to use 393. You can do it all in one go on your calculator, and it'll come up with the mass of gas, which in this case is 2.66 kilograms, equals the mass. So, you know, quite a lot in it. Thank you very much. So that's the answer. So all we've done is we've found the mass of gas under a certain pressure and a certain temperature. And all we've done is use that formula there, which you've seen previously, and just moved it about a bit, and so we can find the mass. The only thing you'll be careful about is making sure that your temperature is in Kelvin, and then just put the numbers in. Okay, so there's my ATEB, there's my answer. Thank you very much. North Star. See you later. Over and out.